Good morning, everyone, and welcome back to the next session of the Horizon Cloud Summit. I'm Mark Dietrich, Senior Advisor at EGI Foundation and part of the Horizon Cloud project. And today we're going to have a session about research challenges in cloud computing, a bit of a deep dive with a lot of key people in this space. So it should be a great set of presentations. And I'm going to introduce now Lutz Schubert, Dr. Lutz Schubert, who is head of research at the University of Ulm, working on cloud computing and internet-based research topics. So a great span of experience there for many years. And prior to that, he was head of research working in high-performance computing at HLRS in Stuttgart. So a pretty broad remit there and set of background. So I'm hoping that that Lutz will join us and we can get this process started. Hello, Lutz.
Hello, Mark. Thanks a lot for that introduction. You make me sound old. Thanks for that. In any case, hello, everyone. I'm glad that you all joined this very interesting session that we've got set up. We've heard a lot about what cloud can do and how cloud is employed and everything in the last few sessions and over the days. But a question that I often hear, in particular from my students and research colleagues, is what are the remaining research challenges? And of course, we all know that there are plenty of issues still open to be addressed that still don't work in the way that we want them to. And of course, there's upcoming and new challenges being posed whilst the technology changes, whilst the environment changes. Of course, COVID-19 is a great example of how our use of the internet changes over time as well. So we've got a very interesting line of speakers coming up. As you can see here, we start with Klaas Berenga, who's the Chief Information and Technology Officer of GEANT. Then we'll go over to Geir Horn, Head of European ICT Projects at the Oslo University, who will tell us about Morphemic, and then we'll turn over to Dimitru Roman, I hope I pronounced that correctly, who is a senior research scientist at SimTab, and who will tell us more about big data pipelining. And we'll close the session with Patrick Jauerning from Technical University Darmstadt, where he's a researcher, and he'll particularly talk about confidentiality. So as you can see, we have a lot of interesting topics to discuss, and we don't have a lot of time. So in the interest of time, what we'll do is we'll let everyone talk for roughly 10 minutes, and we'll collect all your questions. So please use the chat box to ask any questions that you may have, and we'll come back to your sessions after we've heard, to your questions, sorry, after we heard all the presentations. So without any further ado, in interest of time, I'll hand over to Klaas. Thanks a lot for joining us, and I'm looking forward to your presentation.
Thank you very much, Lutz. And yes, I'm afraid we have to admit we are already old. Yes, so to give a little bit of my background, prior to coming to GEANT, I worked for a number of years in Cisco Cloud Services, where we set up cloud environments for customers. And as CITO at GEANT, I'm also responsible for our cloud activities. And when I was asked to talk a bit about the barriers for adopting cloud services for research, I started to look at what I could find on the internet, what articles about barriers for adoption. I talked to some of the people in my team that are heavily involved in the OCRA project, the project that aims to deliver commercial cloud services to researchers. And I essentially made a word cloud of the words that I came across there. And there are really two that stick out very much. One is security and the other is compliance. And I think that in addition to some other concerns that people may have about things like costs, things like having the right personnel, etc., I think consistently these two come back. And if it was if this was a live event, which I very much would have liked, but well, I guess that goes for all of us, I would probably now ask people to raise their hands if they were using Google Docs ever, or Dropbox, or a whole bunch of cloud-based services that would, in principle, suffer from the same barriers as the use uh, of research data. I mean, you might argue that research data is more valuable, but I can tell you that I probably care more about my own bank details being found by someone else than my research data be found by someone else. So that may be on the societal level, maybe a different story, but from a personal perspective, that is true. And I think that is something that that is a very important notion to have, that when you start thinking about using the cloud, and when you are starting to think about security implications, about compliance issues like GDPR, Schrems 2, etc., I don't want to say that they are not valid concerns. Definitely they are. Just like I don't put my tax records on my Dropbox, I also want to think about where I put what organizational, what research information where. And but what I think would be a big mistake is to use these concerns as a reason not to go for the cloud. And the speakers that come after me will show some of the incredible benefits that you can achieve by using cloud technology. And I think the key word here is, what is the nature of your workload? And I think you need to be cognitive about what your security, your compliance, etc. requirements are. But you will find, as we have found when we inside Shayant went through the same process, we have found that in reality there is not that much that would not be possible to put it in the cloud. Of course, put it in the cloud under certain conditions. And that is what we have seen developing over the last couple of years. The big hyperscalers have set up data centers in the EU. They have sometimes put up Chinese walls between their EU the subsidiaries and the larger Chinese or American companies. So a lot of the compliance worries are already much less than they may have been in the past. And I also would like to ask you to answer honestly the question, when it is about security. Do you really think that your internal systems are so much more secure than a storage in a system where there is a dedicated team of many engineers securing that data? So there are lots of considerations, and for me it is clear that moving to the cloud is not the answer to everything, but in reality it is the answer to a lot of things. And before handing over to the next speaker that will go more into detail what kind of things you can do by moving parts of your workloads to the cloud, I want to use my last slide. And I have to admit, I of course cheated on this one. I just added 50 times perception in the word cloud, and guess what? It turned out as an important word. But I think that is really very much it. I think the cloud is something that is new, scary, doesn't fit very well with your current way of doing things. But what we have found is that by moving to the cloud, you can really gain a lot of scale advantages, and in many cases, the security and compliance risks that are certainly there can easily be overcome by careful designing of what you're going to do. And with that, I'll hand you over to the next speaker. Thank you.
Okay. I hope that everything is well and you can hear me well. I'm going to talk about, my name is Geir Horn from the University of Oslo, and I'm going to introduce briefly the Morphemic project and what we are doing in the application management domain. Because there are two views on cloud, and one is from the data center perspective. You can't hear. You can't hear me? Let me see. I can try to increase the volume of the microphone. Okay. Sorry about that. I got a message that someone couldn't hear me, so I will continue. So there are two views on cloud computing. One is from the data center perspective, where how do we manage all this incoming load? How do we schedule this on the available computers? And the other one is from the application perspective, where we look at what kind of resources can we use in the cloud and how can we manage our application in the cloud. And we are looking at a particular kind of applications which we think is broad enough, which is distributed, of course. They must be. They consist of components that are communicating. They consist of microservices and services. So this is typically built up of a cloud-based application. In addition, you can also have functions that you are using provided by the platform operator. And these applications typically are running for a long time, so you will have variable resource demands. You will have users coming and going. You will have situations where the application has to be reactive to what happens around it. And of course, for you as the owner of the application, when you deploy something to the cloud, you want to have control over the cost and the performance and what your users get out of your application. And as I said, the application is also assumed to be sort of long running, because if you are deploying something which is going to run in the cloud for 10 minutes, then you can easily do that yourself. And since we are producing a management platform for applications, the application itself is a black box to us. So we do not know, and we do not need to know what kind of application you are deploying. The only thing we need to know is how are your components connected together. So no code should be necessary in order to do this management. And these are sort of the application level challenges that we are addressing. Then if we look at what we Hello? Okay, so what we are adopting is the autonomic computing loop, where we start with an application model, which is then subject to analyzing and planning how do we best execute this model, and then we execute it and we monitor it. So in the first step, we are going to So the first the user must do is to describe the application, and then once the application has been described, we will solve an optimization problem to find the optimal placement of this application. And then once this optimal deployment has been found, we will go through and actually execute that optimal schedule, whether that is an adaptation of a running application or whether that is a completely new deployment of the application. It will still be done in that way. And then finally, when the application is up and running, it will be monitored and we will collect data about this application. And what is unique in this feature is that we're not only collecting data from the cloud providers or from the machine side, so CPU load and memory requirements, but we are also monitoring user level or application level metric values, like for instance, the number of users or the location of users or whatever is important for the application itself will be or can be monitored and should be monitored if it is important for the analyzing, the planning, and the execution of the deployment. And we build a platform which is called Melodic that actually does this. It starts from a model of the application, it does optimization, cross-cloud deployment, and then it does monitoring of the running application, building a context awareness. Is it necessary now to change the deployment or adapt the application to the different circumstances, we use a models at runtime approach, which updates the model, and then we start again. So this is already done. This is a reactive loop, which is sort of responding to changes in the environment, and it would work fine if it was such that the cloud deployment would be instantaneous. It's not. So that means the user, when dealing with multi-cloud deployments, must face different challenges. For instance, there are permanent load should probably be on private infrastructures, and what you can do as a temporary load, variations in load, can be used, using the rented resources, so in the cloud basically. Today, it's also more and more common to use hardware accelerators like GPU, TPUs, FPGAs, and cloud providers are providing these. And this must be included into your decision about where to deploy and when to deploy and how to deploy. And then you have the cloud continuum. So you have no longer all jobs provided, submitted to a data center, but you have to take into consideration the whole range of deployment patterns from the data centers up to the edge nodes where you might not have sufficient computing power. And then again, if you go with one cloud provider, you suffer from the vendor lock-in, so you are sort of paying the price the cloud provider is asking you always. If you have a multi-cloud approach, then you can freely move between cloud providers. And then, of course, you also have legal constraints. So some data, for instance, subject to GDPR, can only be hosted in Europe, and that you have to take that into consideration. So what we talk about is an adaptive situation where the application is self-adapting to the execution context and the changes that the application is experiencing. So we start with an initial deployment, and then we are doing measurements as time goes on and the application is running, and based on what we are monitoring, these monitoring events can come at sort of different times over the time span of the application. But at one time, say at time 3, we detect that not everything is okay. There is a problem with this application. It's not serving the users as good as we want, so we would like to start and find a new solution for it. And then it goes to the solver, and then the solver finds an optimal application configuration, which is then being subject to the adaptation, and finally it goes into the reconfiguration stage, and the application is up and running reconfigured. But that might be much later. So that might be in time 28 in this example here, time point 28. This might be, at time point 28, we are basically deploying the application configuration as it was in time point 3. So from this point of view, it's better to predict what would be the situation at time point 28 and deploy the application as if that would be the case. So that means we are introducing a forecaster. With this is closely connected to the event management system, so it gets the in measurements as they are taken. Then it detects when the service level objective is violated, so when a reconfiguration is needed, and then the whole loop starts again, but this time it starts on the basis of the estimated context of the future time. So in this sense, the solver will produce the optimal configuration for the future time, and eventually we will actually deploy this future configuration for the future time, and it will be correct. So this is one challenge that we are addressing now in Morphemic. And the main issue here is, of course, to ensure that the forecasters of a multivariate measurement series is actually doing good predictions, because if the predictions are bad, then we are doing bad reconfigurations as well. So this is one thing which has to be looked at. The other thing we are looking at in the Morphemic project is polymorphic architecture. So one component can have many different implementations. It can have implementations for CPUs as a virtual machine. It can be containerized. It can be a function, which is again running on a normal CPU, or it can have different flavors like a GPU or an FPGA version, which will help it to speed up in certain situations, but they are also much more costly to deploy, which again will make it more challenging to deploy everything on an FPGA always. So we will probably use a mix of the component deployments. And then, of course, the component can be attached to big data frameworks, which is already provided as a by the platform provider. So all of these considerations represent a polymorphic architecture. And in addition to finding the best number of components to deploy, we also have to find the best form of the component, or one component can even be delivered in many different forms and deployed on many different clouds in different forms. So this is sort of the application problem. And if you bring in here that this component can be deployed in the core cloud, the data center, or at the edge, then you will sort of certainly see that planning and optimizing this at runtime is actually quite a challenging task that we will work on continuously. And Morphemic platform will have a solution for this in a year's time. Currently, we're able to support proactive adaptation, but this polymorphic architecture adaptation we can not yet fully support. So thank you.
Hello and good morning, everybody. My name is Dumitru Roman, and I'm going to give a presentation about data, especially data processing in the context of computing continuum. And of course, is that topic is related to the cloud. The cloud is part of this computing continuum. More specifically, I'll focus on the concept of data pipelines and how we manage data on this computing continuum, both in terms of data being generated from the computing continuum, but also processed in. And in this process, we also hope to build a kind of ecosystem where different stakeholders can interact on managing data pipelines on the computing continuum. I'd like first to start mentioning that this work is part of a project which is called DataCloud, which stands for Enabling the Big Data Pipeline Lifecycle on the Computing Continuum, that has been funded by the European Commission under ICT 40 call. It's a research and innovation action, so we look at more the research aspect of this topic. The project started this year and will run for 3 years. The website is already online, so you can check it out. It's datacloudproject.eu. Basically, what we are trying to do here is create a software toolbox that we can support various stakeholders in managing the data pipelines and the life cycle of data pipelines on the computing continuum. We also look into creating some examples in various domains like digital marketing, live media streaming, healthcare, predictive maintenance, and Industry 4.0. The project is led by Syntev, which is the organization that I represent here, and we have partners that come from academia like Sapienza University of Rome, University of Klagenfurt, KTH, and KTH. I executive, we take our technology providers, and the others listed here like Bosch, Jot, Og, and so on are use case providers. So what's within the scope of this project? It's basically the central to the project is the concept of data pipelines, which we define as composite pipelines for processing data with no trivial properties and characteristics. We commonly refer to them as the V's of big data. Can be volume, so large amounts of data, variety, and so on. So this picture here depicts our assumptions at the bottom, where you have different infrastructure elements like cloud, edge, fog intermediary, computing elements, and we assume that data is generated through these infrastructure elements, but also needs to be processed on this infrastructure element. So when we talk about the life cycle of data processing, or specifically pipeline processing on this computing continuum, would look at different aspects. So one would be, for example, the discovery of pipelines. So there is data spread all over the place in different stores generated by different sensors stored on the cloud, on servers, can be processed also on the edge. So the question is, how can we look through all the information, log files, for example, log information to detect events that contributed somehow to this processing of the of the pipeline. So one topic is discovery of the pipeline. Then once we kind of discover some skeletons of the pipelines, The question is how we define these pipelines in a way that we can deploy them on Computing Continuum. We look at simulation. So once pipelines are defined, how can we ensure that what we define can actually run on the infrastructure? So is this problem of simulation of the pipelines. Then we will need to provision the resources for executing the pipelines. We need to deploy the pipelines and the runtime of the pipeline. So none of these areas that are mentioned here are solved for big data in a big data context. So we look at each of them individually, but also as a kind of life cycle for supporting the management of the pipelines. So in order to have a concrete example, think of some data that is generated at the edge, then it's archived to be transmitted more centralized place. Let's assume that the data is tab separated value, but you want to convert it to comma separated value. Then data is probably so big that you want to split in the different chunks. You apply some transformation to the data, and in the end you want to store it for further processing. So if you have a 30 gigabyte file, this is not easy to be done on a single machine, so you need to utilize all this infrastructure from edge to the cloud to be able to create such pipelines. So the project is about how can we support such pipelines and how can we make use of the infrastructure to do this in the most suitable way. So I mentioned about the ecosystem. So we see a number of stakeholders that interact in the context of this pipeline. So on the left-hand side, we have data providers that actually come with their data, and then data consumers that want to get something out of the data. Well, then in this process of identifying pipelines, we also have the business domain experts that have domain knowledge into how data is generally processed in their domain. We have the data scientists that apply different algorithms, different methods on the data, and we also have the computing continuum infrastructure maintainers. In this context can be data ops, but we also at the bottom we see the resource providers that bring their resources into the ecosystem. So the way how we see this is that data providers have this what we call dark data, which is basically all these log files or the data that is used to then apply some sort of AI-driven process mining techniques to discover the pipeline. Then we have the stage of definition of the pipeline, where domain experts and data scientists collaborate in order to instantiate different steps of the pipeline. Then at this level, we also have the pipeline simulator, which simulates how the pipeline will actually be realized on the computing continuum. Then we have all these different elements for resource provisioning from the resource providers that come in with possibly untrusted resources. So here we have this notion of also the resource marketplace, where you have need some secure transactions in terms of what is offered in the marketplace when it comes to resources. Then we also have the deployment of the pipelines on this continuum computing infrastructure. And all these things happen at the design time, so before actually pipelines are executed. Then at runtime, we have the big data coming from the data providers with all these characteristics, volume, variety, veracity, and so on. They are fed into the computing continuum infrastructure that executes the pipelines, possibly with adaptation in terms of resources coming and going outside of the ecosystem. And in the end, the results of these pipelines will provide some sort of insights into data consumers. So the whole point here is to have some sort of separation of concerns between various stakeholders, at the same time collaborating into supporting this life cycle of data pipelines on the computing continuum. I will give a couple of examples that we are looking at. So one is in the area of healthcare, remote patient monitoring, where we work with one partner is healthcare solutions provider that basically have a system, cloud edge system to follow up patients suffering from chronic disease. patients report their own physical and mental well-being from home, possibly with the use of sensors. So on the left-hand side here, we see a patient that has access to some sensors. These sensors will provide data to a edge gateway, which preliminary transforms, collects the data before sending it to the cloud in the middle. And on the right-hand side, we see various stakeholders from the healthcare domain that make use of this data and also interact with the patients, like doctors, specialists, response operators, and so on. So the question here is, how can this pipeline of processing data from patient to the cloud and to the stakeholders on the right-hand side can be customized and multiplied when new patients, when this system is installed to new patients. So here we hope to get some sort of reduced timing costs and improved testing capabilities for the pipelines when it's deployed to a new customer or new patient. How can we ensure better control and more efficient deployment of the pipelines on this, both on the cloud and on these gateways, and improve the whole scalability of the whole process. Another example that we are looking at is automatic live sports content annotation. So you can think of various cameras being installed on a stadium, and we would like to annotate all the video data that is coming from all these various cameras in order for broadcasters to enhance audience management. So we have all sorts of problems here with computation costs and so on that we are looking at. So the way how we see a pipeline in this context is that you have multiple video sources on the left-hand side. There's some sort of video preparation, video ingesting, like encoding the video to be sent to the cloud, where it's decoded. So various AI event detection techniques are applied, and data is annotated and then can be archived, for example, for future search. So how this could look like in the end, you have a football match from the left-hand side taking that is recorded, and on the right-hand side, by executing this pipeline, you will basically be able to identify the movements of the players, the ball, and all of additional information about all these elements that are detected. So the way we see here is that you apply all these stages of the pipeline and the tools that we are proposing here. For example, the definition of the pipeline is to configure the pipeline. Simulation is to ensure that this pipeline can run on the available resources, adaptation, and so on. So there is some sort of chaining of steps where data can be processed, where various infrastructural elements have to be taken into consideration. So we are currently developing this toolbox where we see various configurations of the tools. I'm not going to go into details in this picture. I just want to highlight the fact that different components of different steps, like for example for discovery pipeline, where we do event data extraction, pre-processing, and event log generation, discovery of the pipeline can be easily changed to the pipeline definition. So this dev pipe more in the middle, where we use some techniques coming from domain-specific languages, software containers, to wrap various steps of the pipelines into containers so that we can ensure scalability on the computing continuum. So the idea is to build this toolbox that can be chained together and easily used for different configurations depending on the use cases. So some final remarks. As I said, the project started this year, so we are in the phase of defining and understanding these business cases when it comes to the needs of data processing, but also on the computing continuum, the infrastructure aspect. We are defining the architecture and technical components of the toolbox that we are developing. And we also have some preliminary implementations of these various components that realize steps in the life cycle of big data pipelines. Some things that we find kind of difficult is discussion of toolbox versus platform and the complexity of building a platform versus a loosely coupled toolbox. We also see that abstraction of pipeline definition is not always evident, so that there are various levels of abstractions that you can look at pipelines, and we are also creating this domain-specific language for the pipelines where we try to see what's the right level of abstraction and what kind of elements this language should have. And we also see that even if you have this nice continuum computing infrastructure, not all data processing can be made scalable, especially from legacy systems that were not designed in components that each one individually can scale. So I'll end here. Thank you very much for your rotation and for attention. And if you have any questions, I'll be happy to answer. Thank you very much.
Hey, thanks, Dumitru, for this interesting talk, and welcome to my talk from confidential cloud computing to next generation edge computing. My name is Patrick Jawanik. I'm working on the Sanctuary spin-off project at the System Security Lab at Technical University of Darmstadt. And in this talk, I will go through the current state of confidential cloud computing and how we can leverage our insights we got there to build a cloud edge ecosystem that is leveraging security primitives. Who are we at Sanctuary? So this is our team. Besides me, there's Emanuel, Ferdinand, and Professor Zadegi. We're all in the field of security architectures and come from the System Security Lab at TU Darmstadt. The System Security Lab mainly works on software and hardware security, IoT security, and also security for machine learning and vice versa. So Sanctuary is a spin-off project with a goal to fund an actual startup. And we're currently funded by the Startup Secure project of the German Ministry for Research and Education. And now let me show you problems and opportunities in cloud research and what we at Sanctuary are doing there. So nowadays, many services are outsourced from on-premise servers to the cloud. This also happens with very sensitive services, for example, in health or in infrastructures, where health has also been mentioned previously, so it's a big trend. And we have a tool to actually make this GDPR friendly, but also protect our data, which is confidential computing. Confidential computing leverage the power of trusted execution environments, which is a technology to strongly isolate a sensitive service from the remaining software that is running on the system. This can be like an operating system, this can be a hypervisor, or other applications. And this technology is key to European sovereignty because it reduces influence of non-European software by excluding it from the sensitive services software stack. And these trusted execution environments, or TEEs, are available from all major CPU vendors. Like there's Intel SGX, there's AMD SEV, there's ARM Trustzone, and recently they introduced CCA, the confidential compute architecture. And especially the latter is very important because in the EU, there is a funding project which is called the European Processor Initiative, and they are building some kind of European processor out of this ARM technology. A big problem we have is that this confidential computing is currently very inflexible. So currently you as a user or customer, you have to adapt your workload to the underlying TEE technology. This limits the capabilities of a workload itself because, for example, the TEE might not support talking to external devices, as we heard previously, accelerators like GPUs. And this new compute model also leads to complex deployment and management with dedicated tools you don't know from the rest of your cloud native tool stack. So how can we overcome these problems? So there are currently already container approaches that allow confidential computing based on AMD or Intel SGX. But as I said, this still forces you into this compute model, which is not the one you actually know from your previous applications. So how can we overcome this? First of all, we need to have the cloud native tools we know, most of them, which is orchestration. And to actually do something like a secure orchestration, we need to leverage trusted execution environment functionality, which means if we want to deploy something or manage something, we should get an authenticated integrity measurement to prove that our workload has been deployed. And we are indeed talking to this very workload and not to an adversary, which could be like a malicious employee at the cloud hoster. So this is a problem we looked at recently in a paper, which is currently under submission. I put it in the corner of this slide, and if you're interested, just drop me a mail. But there's also a second technology to overcome this. We need new TEs that are more flexible. So things like Intel SGX support general purpose workloads, so pure computation on the CPU reasonably well. But as I said, accelerators are still a major problem. So let's see what we can do at the edge. Now we have so many learnings from confidential cloud computing. There must be something we can do at the edge, and edge is very trendy. It's important. The devices get much more powerful recently with more advanced ARM processors being used. We also have a much better connection with them due to 5G with low latency and high bandwidth connections. And edge embedded devices are also extremely important for future use cases. For example, if you look at autonomous cars or V2X, you need them for a timely response. You cannot just talk to the cloud and wait and do something. You need some holistic ecosystem that allows the car to react in time, but also to get a consent from the cloud. And more importantly, they are crucial to privacy because they can also pre-process all the information that gets created in these devices. Like a car has a lot of personal information. If you want to, you're sitting in it, can monitor you the whole time. So how can we transfer our learnings? Because actually these edge devices, more specifically embedded devices, they are highly individual systems. For example, a car can comprise more than 300 control units, which consists of a processor, but also software running on it. And also deployment and management on such systems is much harder than on the cloud because it's so diverse. So what we do at Sanctuary is we try to solve the former problem by consolidating the services that are on these individual control units in the car example using virtualization. So you can actually deploy your control unit as a software workload. And we also use TEEs, namely for security services, because they allow you to check if the system that you're running on is in a valid state. So in the car example, given you're a car manufacturer, like a very trendy one like Tesla, and you sell paid upgrades to unlock battery capacity, you want to prevent that anyone circumvents your payment procedure and can just unlock it for free or much less. So our system can actually report to Tesla that this car that is trying to upgrade is in a valid state, that is authorized to upgrade, and can so prevent unlocking upgrades without paying. And the last challenge we address is combining this with the tools we know from cloud development. So which is all the cloud native tools. So takeaways from this talk is that confidential cloud computing is possible today with some caveats because there's still a lot of tooling missing to make it like a natural experience. And what is more important is for the future, we need to bridge that gap. We need to create an ecosystem that connects cloud and edge devices, especially embedded, to be ready for future use cases like vehicle-to-X communications. And this has mainly two requirements. So first one being we need strong authenticated integrity reports via TEs, which is currently also, for example, looked at for sensors in a research project at our group. It's an EU project called Assured, which is exploring the concept of systems of systems. And finally, we also need to make edge devices work with the cloud workflows we know natively. And if you're interested in these topics, feel free to contact me either by mail, which I put on the slides, or feel free to also visit our preliminary website, which you can also find at sanctuary.dev. And thanks for your attention.
Wow, thanks a lot, everyone, for these interesting presentations. We covered a lot of ground there, and that's, for me, specifically interesting because one thing that it shows for certain is that we all have slightly different perspectives on what cloud actually is and what challenges it poses, and in particular, what large scope of use cases we cover with that, and therefore, basically, we pose the almost impossible requirement towards, well, clouds, whatever you want to think that be, to fulfill all these requirements. And we have a notion of that they should all be equally fulfilled. But in reality, as we can hear from all these presentations, it depends very much on what kind of use case you have and what kind of requirements in a specific environment you have. So fortunately, or rather unfortunately, I was going to say we still have time for questions, but unfortunately we have very little time for questions. So we have a series of questions from the audience. There is one question which I think actually is an important question to all of you. So I'll just pose that towards all of you. I'd like you all to individually give you a quick thought on that. So we have a question from Ulrich asking to share your thoughts on security, liabilities, and risk mitigation for users and providers, considering the lifecycle management of data and services. With Klaas, maybe you want to start?
Well, if I talk slowly, the session will be over.
I talk quickly.
Yes, so I think I would go back to what I said in my short presentation. I think there are plenty of use cases where that is important, and I very much support what Patrick was talking about. There are enough use cases where you have to think about this, where you have to have a secure environment. I think, as always with security, it's a balance between the value of what you try to protect and the measures you take to protect them. And I think we just need to be pragmatic about that.
Fair point. Geir, I mean, from your position of difficult distributed management, what do you make of that?
What is important to say, which I didn't focus on in my presentation, is that the melodic and the morphemic platforms, they are sort of for one application and for one application only. So what they aim to replace is the DevOps, the person that is maintaining that application. So ideally, you will run melodic on your own infrastructure, and it will communicate out of your own infrastructure like if it was a human sitting there managing your application. So it doesn't really change the application security model, except that we, in the same virtual machine as you install the application components, we will also install the monitoring components. And we can monitor whatever there is a sensor to monitor. So if the application wants us to monitor the number of users, they have to create an application external sensor, which can be deployed in the same virtual machine that records or get the information from the application and transfer it to our monitoring system. So in other words, we do not interfere with the security model of the application itself. And this is sort of quite important. So it's still the application security model that will define what is the security model for morphemic and melodic.
Thank you. With less than a minute left, Dumitru, do you have a quick position on that from the data perspective?
Well, of course, data can be very sensitive, and security and privacy of the data are essential. And the example that I gave with patients monitoring, that's of course health data that is very sensitive. And these companies that we work with, I have to say they are very careful with being GDPR compliant, and so I see there is a lot of concern about this aspect. So I think I'll stop here because we'll run out. But I just wanted to make a point that this is taken seriously.
Very important point. Patrick, I'm sorry, we're running out of time. I'd like you
Let
all
me
to
say,
check
do
the
security.
chat.
It's important.
Yes, we all agree on that one. Thank you, Patrick. Because we're running out, once again, thank you all. I think I'll have to pass back to Mark to wrap this up. But once again, thanks for the presentations. And everyone, use the contact to chat with them. And please have a look at the chat questions as well. Maybe you can talk to the people directly with all the other questions we got. Thank you all.
Thank you.
Thanks for all those thought-provoking presentations. A great deep dive into these complicated issues that we need to sort out pretty soon if we're going to deploy and expand the cloud-to-edge compute continuum. So stay tuned. In about 9 minutes, we're going to be moving to the next session, Accelerating Cloud Business Innovation. And we'll move from the complicated research challenges to the complicated business challenges. So thank you very much.